of heart lung machine and the ECMO. So first I will introduce myself. Myself Mognavalli, working as an assistant professor in Department of Biomedical Engineering in Erode Sengonda Engineering College. So today we are going to see about the topic of heart lung machine and the ECMO. So heart, from name itself we can able to understand heart lung machine, which is nothing but this machine is going to perform the function of both heart and the lung. So this is called as the heart lung machine. Then ECMO, so the abbreviation of ECMO is extracorporeal membrane oxygenation, which is nothing but this ECMO is mainly used to provide the oxygen to the blood. So for that we are using the ECMO. So this is the diagram of this is the picture of the heart lung machine, which is used in the operation theatre for mainly to bypass the function of the heart and lung with the help of the heart lung machine. So here there will be a heart lung machine. So a doctor is using the heart lung machine to provide the amount of oxygen to the patient, and also he will control the amount of blood flow to the patient. So let's we see what are the components involved in heart lung machine and where it is used and when it is used. Like that we will see in the upcoming slide. So first, a medical equipment that provide cardiopulmonary bypass, which is nothing but a temporary mechanical circulatory support to the stationary heart and the lungs. So cardiopulmonary, so cardio means which is nothing but heart, pulmonary means lungs. So it is going to bypass the heart and the lung to the where it is used to the stationary heart and the lungs, which is nothing but so the heart and lung if is not performed the operation with the help of heart lung machine, we are going to perform the normal function of the heart and lung. So normally the heart lung machine is called as the electromechanical device, because mechanical means the blood will be flowed. So the pumping of the blood is called as the mechanical, and the electrical, which is nothing but a stimulation of the heart, because the contraction and the relaxation of the heart, based upon that contraction and relaxation only the blood will flow to the other parts of the body, and also the blood will come to the heart also. So based upon this electromechanical action only our heart and lung will function. Same, the heart lung machine is also a electromechanical circulatory function. It is going to circulate the oxygenated blood to all the parts of the body. So the heart and lungs are made functionless temporarily. So we just stop their functions for temporary use, okay, in order to perform surgeries. What are those surgery means? CAPG. So CAPG means coronary artery bypass graft. So coronary artery means the coronary artery. So the artery, from the artery the blood is supplied to the coronary artery. It is mainly used for supplying the blood to the vein. If there is any damage in that coronary artery means we are using for that operation we are using the heart lung machine. Then valve repair. So there are 4 valves present in the heart. If there is any damage or any obstruction in the valves, we are going for the valve repair. Then aneurysm. Aneurysm is nothing but a bulging or ballooning of the aorta in the aorta region, that is called as the aneurysm. And septal defects, which is nothing but the heart consists of the septum region. So in that septum region if there is any damage we are going for the surgery. So for these 4 conditions, whenever we are doing procedures, okay, we just temporarily stop the function of heart and lung. Instead of the function of heart and lung we are using the heart lung machine to provide this oxygenated blood to other parts of the body, because whenever during the operations we can't able to stop the other function of our body. So for that we are supplying the blood to the other parts of the body, because all the parts are mainly depends upon the supply of the blood. If the blood supply is not provided to the other parts, then that parts will not started working. So the first operation involving open heart with temporary mechanical takeover of both heart and lung on April 5, 1951 at the University of Minnesota Hospital. So they just provide the temporary mechanical action by stopping the function of the heart and lung. So the patient did not survive due to the unexpected complex heart defect. So the first operation will be a failed one in 1951. So the first successful open heart procedure on a human utilizing the heart lung machine was performed on May 6, 1953 at the Thomas Jefferson University Hospital in Philadelphia. So the first operation is not a successful one, but in 1953, which is nothing but they are doing the open heart surgery with the help of the heart lung machine. So it is this successful one. So the first operation was did on the 1953. So next we check, okay, so there is a heart lung machine, which is nothing but we are going to take the blood from the heart and get oxygenated with the help of the lungs, and then it is applied to the other part. So consider there will be a heart, which is nothing but it consists of right atrium, right ventricle, left atrium, left ventricle, superior inferior vena cava, then aorta, pulmonary artery, pulmonary vein. These are the parts which is mainly involved for supplying in the circulation. So from superior vena cava and inferior vena cava, this is nothing but a blue arrow from the two parts. It is mainly consists of the deoxygenated blood. So from this deoxygenated blood, first we take the blood and stored it in the reservoir. So the reservoir is, which is nothing but it acts like a storage container. So it just stores the blood for the long period of the time. Okay. So in reservoir the blood is present. That blood is the oxygen poor blood, because we are taking the deoxygenated blood only. So in reservoir also it is in the oxygen poor blood. Then it is given to the oxygenators, because we are supplying the oxygenated blood only to the other parts. So from the reservoir the oxygen poor blood is getting oxygenation, and then it is again pump. With the help of pump we are again circulate this blood to the aorta, because the main function of the aorta is to supply the blood to all the parts of the body. So again we giving it to the aorta to supply the blood to the part. Okay, so these are the three components mainly used in the heart lung machine. One is reservoir for storing the blood, and oxygenators for getting oxygenation or providing oxygen to the blood. Then pump. So pump is mainly used to making the flow from one place to another. So for that we are placing the pump. So this is the overall representation of the heart lung machine. So it totally consists of the 5 pump heads. Okay, let's see. So first there will be a right atrium, right ventricle, left atrium and right ventricle. In the right side corner you can able to see the heart. Okay, so from that the 5 pumps are used. One is nothing but the 4th and 5th pump, okay, which is mainly connected to the coronary artery, and then so the third one is connected to the suction tube. So the suction tube means whenever we are doing the procedure means the blood will be wasted. That waste blood, which is waste blood means which is nothing but a leaked blood. Okay, that leaked blood is collected with the help of the suction tube, and it is provided to the pump head 3, and then pump head 2 is connected to the right ventricle, which is nothing but from the superior and inferior vena cava the blood is flowed to the right atrium, and then from right atrium the blood is flow into the right ventricle. So from the right ventricle we are collecting the blood, and it is given as a input to the pump head 2, and pump head 1 is connected to the aorta. So there will be 2 pumps which is taking the blood from the heart, and 3 pump which is giving the blood to the heart to the other parts of the body. Okay, so from this pump 2 and 3, so this 2 and 3 pump is mainly taking the blood from the heart. One is from the leakage for sucking the leakage blood, another one is for taking the blood from the right ventricle. These 2 pumps are mainly used to pump the blood from the heart to the reservoir. So in this diagram we can able to see two connection, okay, second and third pump connection is connected to the reservoir. So as I already said, reservoir is mainly used for storing purpose, okay. So from the storage we are again given it to the oxygen membranator, okay. So in this, it consists of, this diagram consists of oxygenators and the heat exchanger. Because already our body has some normal temperature, it should be maintained throughout the time period, because so then only the blood will also, the red blood cells and white blood cells are in live condition. If the temperature is varied, the blood flow will not proper, okay. So the flow of blood will mainly depends upon the number of red blood cells and size of the red blood cells, and also the temperature and also the blood pressure. So these are the main components which is mainly for providing the normal blood flow to the heart. So in this, it consists of the coil, which is nothing but it is there will be a spiral coil, so which is nothing but it is a heat exchanger coil for providing the adequate temperature to the blood which is from the reservoir, okay. So then is added with the nylon, and there will be a nylon mesh filter. Why we are using nylon mesh filter means, if there is any contamination or any other particles present in, means we are just filtering it, okay. So then we are and then blood dispersion plate, okay, from that the blood will be flowed, and from the O2 side, which is nothing but O2 side, the O2 dispersion plate is used to provide the again oxygen to the heart, to the other parts of the body. So from that there will be two connection. One is connected to the femoral artery, which is nothing but an aorta. So the pump one, you just see from the oxygenator there will be two connection. One is connected to pump 1. So from pump 1 it is connected to the aorta for supplying all the blood to the other parts of the body, kidney, livers, and some of the muscles. For all these things we are supplying the blood. And there will be also another one connection which is connected to the pump 4 and 5. This is mainly to provide the blood to the coronary artery. So the coronary artery is connecting the heart to the brain. So because the brain also have to function, okay. So if the brain is stopped, all the functions will always be stopped, okay. The patient will go into the coma condition. So it also requires adequate amount of blood. So for that we are using the coronary artery to supply the blood to the brain. So the pump 4 and 5 mainly used for pumping the blood to the coronary arteries. So this is the schematic representation of the heart-lung machine. There will be also the water pump and the temperature controller. With the help of temperature controller we can maintain the temperature, and the water pump also. So as I already said, there is a 5 pump heads. 2 is for perfusion from the heart, and 3 pump is for perfusion to the heart, okay. So 1 for perfusion of the body, which is nothing but the second one, which is taken from the right ventricle. Then 2 suckers, and the 2 for perfusion of the coronary arteries. 2 it is mainly for the supplying to the coronary arteries. So first, the main perfusion system, which is nothing but the pump 1 is connected to the aorta. So the pump head 1 and the combination of the heat exchanger and oxygenator, because this is the main perfusion system, because with the help of heat exchanger and oxygenator we can get the oxygen, and the pump head 1 is connected to the aorta, it supplies the blood to other parts of the body. So this is the main perfusion system. So as I already said, the heat exchanger consists of water coils and a temperature controller that permits the pump oxygenators to keep the blood at a proper temperature and compensate the heater loss to throw radiation from the lines. So mainly the heat exchanger is mainly helps to maintain the temperature throughout the process with the help of the heating coil. So the blood flows from superior and inferior vena cava to O2 minus side, which is nothing but it is given to the reservoir, okay. The pump head 2 went blood from the right ventricle. So the pump head is collecting the deoxygenated blood from the right ventricle, and pump head 3 is used to suck the blood during surgery, which is nothing but the leakage blood or any other blood during the surgery, okay. From O2 positive side, it is taken by pump 4 and 5 to perfuse to the coronary arteries, because 4 and 5 are used to supply the blood to the coronary arteries. So where we are using this heart-lung machine means it is mainly used during the open heart surgery. So during open heart surgery, the heart lung machine, which is also called as the cardiopulmonary bypass, because with the help of heart lung machine we just temporarily stop the function of the normal heart and lung. So that is called as the cardiopulmonary bypass. Cardio means heart, pulmonary means lung, and bypass means we just bypass that function, stop the function for temporarily. Okay, so it diverts the blood away from the heart and lungs into a machine that takes over the pumping and ventilatory function of this organ, because heart's main function is nothing but an pumping action, which is nothing but with the help of that pumping action it supplies the blood to the heart also, to the other parts also. So and ventilation, ventilatory means addition of oxygen and removal of carbon dioxide, and there is a gas exchange takes place in the lungs. These are the process are taken, is called as the ventilatory function. So the machine just take away the circulatory and the ventilatory function. By using CPB, which is nothing but cardiopulmonary bypass, a surgeon can operate on a heart that has been arrested and is not full of blood. Okay, we just stop the function of the heart, not which is nothing but a permanent function of the heart. So the machine uses the gravity to divert oxygen poor blood from the right atrium into the reservoir. So with the help of gravity, now we are taken away the blood from the heart, okay, which is nothing but because first we are collecting the oxygen poor flood either from the inferior superior vena cava or from the right ventricle, from the right atrium into the reservoir. So the main function of reservoir is the storage purpose. So the blood is then pumped through the oxygenator, then it is connected to the oxygenator. So it normally perform the function of the right ventricle, okay, so which removes the carbon dioxide and adds oxygen. This is the function of the lungs. So the another pump moves the oxygenated blood back into the body, which is nothing but to the aorta. From the aorta it is connected to the body. So this is normally the function of the left side of the heart, and thus bypassing the heart and lungs. Okay, so there will be three components. One is reservoirs, another one is oxygenators, another one is the pump. Okay, so the three parts which is related, we can able to relate the heart and the heart lung machine components. So oxygenation means which is nothing but function of the right ventricle, and removes oxygen carbon dioxide and adds oxygen, so it is the normally function of the lungs. And then oxygen blood, with the help of pump we are again pump the blood to the body, so it is the function of the left side of the heart. So normally with the help we can able to perform maximally the same as the function of the heart by using the heart lung machine. There will be a perfusionist. Why we are using why we are taking the help of the perfusionist means, a clinical perfusionist is a trained health professional who operates the heart lung machine during surgeries that require CPB. So CPB means cardiopulmonary bypass. So with the help of the perfusionist we can able to monitor all the parameters of the blood. So the perfusionist maintain the function of the pump, because the main function of the pump is to provide the flow, and monitors the delivery of blood back to the patient. So we are taking certain amount of the blood from the patient, and same amount of the blood will be delivered back to the patient. Okay, and monitors the blood oxygen content, because it is one of the most vital parameter, because if there is any depression of the oxygen means then that some of the organs will not perform properly, and other vital parameters. So these parameters are mainly monitored by the perfusionist. In addition, the perfusionist ensures proper drug delivery and anesthesia to the patient while in bypass, because whenever bypass means nothing but whenever you are during the open heart surgery means, so we have to monitor the patient whether they are in anesthetic mode or whether they are in the normal mode, because if they are in normal mode means they can feel the pain. With the if they feel the pain means they will then surgery will not be in the proper one. So they ensures the proper drug delivery and the anesthesia to the patient during the CPB. So we just see what are the modular technology and the current technology, what are the components involved in the heart-lung machine. So in the heart-lung machines are modular in design and at the basic level. So first level, it consists of several roller pumps and oxygenators and several types of sensors and the centrifugal pump. So it just consists of pump, oxygenators, heat exchangers and some of the sensors. So main function of the sensors in the heart-lung machine is mainly used to indicate if there is an abnormal function or if there is any leakage, means with the help of sensor we can able to know. So new model of bypass machines are becoming more software based and have a central monitor. So in modular machine, in older machines, we are if we have to monitor, means we have to sit beside the heart-lung machine. In the newer technology, there will be a central monitor. From the central monitor console itself, we can able to monitor the heart-lung machine. The central monitor allows the perfusionist to control the settings of each pump, monitor all system sensors and modules, and monitor alarms and error lags and print out a report at the end of the case. So with the help of the central monitor, from his place itself, perfusionist can able to access and control the all the components involved in the heart-lung machines. So this is the current technology. In modular technology, we have to sit back beside the heart-lung machine to control all these parameters. So there will be a types of pumps. The main types of the pumps are the roller pump and the centrifugal pump. In older days, they are using the roller pump. In the now newer technology, they are always using the centrifugal pump. So we just see what is the reason why we are not using the roller pump in the newer technology. So the heart-lung machine comprises a control base that houses all the electronics, power supply components, batteries, communications, power connections and the circuit breakers. So it is nothing but we are just insulating this, that is called as the console. Okay. So that there are typically 4 or 5 roller pumps on an heart-lung machine. So already we see it. One is supplied to the aorta, 2 and 3. So the 2 is taken from the ventricle, 3 is taken from the suction tip, then 4 and 5 is supplied to the coronary artery. So already we see all these things. So for this mainly are using the roller pump. So the roller pump is also called as the peristaltic pump. Okay. So the roller pump peristaltically massage, which is nothing but massage the tube to propel the blood through the tubing. Massaging means which is nothing but the roller pump will compress the tube. By the action of the compression, the blood is moved from one part to the other, because if there is a tube, okay, already we are connected with the tube only. So in the tube, if you are pressing at any one place, means so from that place the blood will be moved to the other place. Okay, so with the help of this action, it is the principle of the roller pump. So the original roller pump designed for a heart-lung machine was first developed by the Michael D. Baker and it consists of 2 eccentrically mounted rotating rollers. It consists of 2 rollers that compressed the tube, which is nothing but that pressed the tube, which was placed in a semicircular loop on the inside of a cylindrical wall. So in the cylindrical wall, it consists of the 2 rollers which is pressed the tube. So the rotational frequency and the inner diameter of the tubing determine the blood flow. So the blood flow, how much amount of the blood will be flowed, it is determined based on the rotational frequency and the inner diameter of the tubing. So the roller pump where we are used means it is mainly used for pumping atrial blood. Cardioplegia. So cardioplegia means which is nothing but it is the ceasing of the cardiac activity. We just stop the cardiac activity, that is called as the cardioplegia, and vent for opening and suction applications. So for this arterial blood flow, cardioplegia, vent and suction application, we are using the roller pump. Okay, so there will be a cylindrical wall. Okay, in that it consists of two rollers. The two rollers press the tube. So by pressing the tube, the blood from that pressed place, it is moved to the other parts. So this is the principle of the roller pump. So we see about the term cardioplegia. So this is nothing but it is a separate circuit for infusing a solution into the heart itself to produce the cardioplegia, that is to stop the heart from bleeding. We just ceasing the heart function. Okay, and to provide myocardial protection. So myocardial means which is nothing but a muscles. So which is nothing but a cardiac muscles. So cardiac muscle protection means to prevent the death of the tissues, because we are not providing the blood. Okay, so for we have to prevent the myocardial infarction with the help of the cardioplegia unit. So next we said in the newer time, most heart lung machine in nowadays are using the centrifugal pump. So now we are using a centrifugal pump for the maintenance and control of blood flow. So if we mainly why we are going for centrifugal blood means for maintenance and the control of blood flow during cardiopulmonary bypass. By altering the how we are pumping the blood means by altering the revolutions per minute of the pump, the blood flow is produced by the centrifugal force. So we already studied in the physics from 7th itself, there will be a centrifugal force which is nothing but based on the center and the rotational, there will be a centrifugal force. With the help of that centrifugal force, there will be a flow of the blood. The amount of blood flow is measured by a blood flow meter placed adjacent to the pump housing. So it is mainly useful because how much blood we can able to monitor with the help of the blood flow meter. So this type of pumping action is considered to produce less blood damage than the roller pump. So the main advantage is centrifugal pump provides less damage to the blood than the roller pump, because the roller pump press the tube. So whenever you are pressing the tube, there is a chance to provide to give the damage to the blood cells also. So it provides less damage than the roller pump. However, unlike the roller pump, which can be fully occluded if necessary, the centrifugal pump cannot be occluded. Occluded means which is nothing but a compression, which is nothing but reducing of the diameter and extending of the length, that is called as the occluded. So the roller pump can occluded up to any extent, but centrifugal is not occluded. The centrifugal pumps are mainly used for atrial pumping and thus augmented venous return pump. So roller pump we are mainly used for the atrial and vent and suction application, but centrifugal pump also used for the atrial pump, and also it is supported as a venous return pumps. So magnetic coupling links the centrifugal pump, which is a disposable item, to the control unit on the console. So with the help of magnetic coupling, we can able to remove the waste also. In addition to offering continuous mode, so continuous roller pump and the centrifugal pump can operate in both continuous mode as well as in the pulsatile mode. Okay, so in addition to offering continuous mode where the blood is pumped at a constant speed, the roller pump and the centrifugal pump offer pulsatile mode where the speed alternates between a peak speed and the baseline speed. So the pulsatile means which is nothing but this will be a diagram of, or it will be a signal of the square wave. Okay, square wave means it may be reach the peak and suddenly goes down and maintains the zero and again goes up, maintain that, again comes to down and maintains the zero. So this is called as the pulsatile mode. Normally the roller pump and the centrifugal pump often provides the pulsatile mode. So this pulsatile mode is meant to stimulate the action of the ventricles, because whenever you are considering the heart, okay, there will be the what it is called as the heart will first pump contraction of the right atrium, then based on the contraction of the right atrium the blood will flow to the right ventricle. Again there will be a relaxation of the atrium, so the contraction and relaxation parts, which is nothing but it is also in the pulsatile mode. So the heart lung machine pump also always operate in the pulsatile mode to stimulate the action of the ventricles. So this is the diagram of the roller pump, impeller pump and the centrifugal pump. So first diagram is roller pump, which is nothing but already said it consists of cylindrical wall. It consists of two eccentric rollers and which is pressed the pump to provide the flow. So that is the first diagram. Second one is impeller based upon the rotation, and third one is centrifugal force. So based upon the center and the rotational force there will be a flow of blood, which is nothing but third one is a diagram of the centrifugal pump. Next one is reservoir. So already we know that. So reservoir is which is nothing but it is a storage container. It store the blood. So the blood is removed from the patient. We already know with the help of the gravity we are taking the blood from the heart and it is stored in the reservoir. So blood is removed from the patient by gravity and temporarily stored in the cardiotomy reservoir. Cardiotomy means which is nothing but there will be a opening and in the heart, so that is called as the cardiotomy reservoir. So this reservoir filters the large particles from the blood. It also acts like a filter. There is also a defoaming agent. Why we are using defoaming agent means to reduce the bubbles in the blood before entering the heart lung machine, because the bubble formation is also one of the main parameter we have to monitor, because if there's a bubbles means if that bubbles break it means there will be a release of oxygen. If more amount of oxygen is also inside our patient body means they also leads to the some of the abnormal conditions. So we have to maintain the oxygen is more important. So we have to reduce the bubble formation, so that we are using the defoaming agents in the reservoir itself. And the reservoirs may be rigid hard plastic canisters, which is nothing but a open type, or soft collapsible plastic box. It may be plastic collapsible plastic box, or it may be a hard container, which is nothing but a soft. This means it is consist of a closed types. So the reservoir function is it mainly venous reservoirs serves volume reservoirs, which is nothing but total volume of blood is stored. Then it also facilitates the gravity drainage. Yeah, based upon the gravity only we are taking the blood from the heart and stored it in the reservoir. So it facilitates the gravity drainage. Then venous bubble trap present. If there is any bubble is present, it will trap that, which is nothing but it will find and remove that, which is it is called as the venous bubble trap present. Next one is oxygenators. So the blood is pumped from the reservoir to the oxygenators or the heat exchanger. So the oxygenator name itself is just nothing but oxygen. It provides the oxygen. So the oxygenator provides the gaseous exchange normally performed by the lung. Already I said lung has a main function is gaseous exchange, which is nothing but addition of the oxygen and the removal of the carbon dioxide. So the main function oxygenators, it perform the function of the, it replace the function of the lungs. So there will be many types of oxygenators. In bubble oxygenators, the finally dispersed oxygen gas bubbles are mixed with the venous blood. So in the venous blood we are mixing it with the bubbles. Okay, at the surface of the bubble the oxygens are diffuses out and the carbon dioxides are diffuses into the bubbles. So this is known as the direct contact gas exchange, because we are in need of oxygen and at the same time we have to remove the carbon dioxide also. So the from the bubble itself we just diffuses out the bubbles diffuses out the oxygen, and also it takes the carbon dioxide from our blood also. This is called as the direct contact gas exchange. Today bypass bubble oxygenators are primarily used for the short term CPB. So for short term, for short duration cardiopulmonary bypass only we are using this bubble oxygenators. Then membrane oxygenators. Membrane oxygenators, name itself we can understand, it consists of a membrane. So the membrane oxygenators introduces a gas permeable membrane between the blood and the oxygen. There will be this membrane will permit only the gas, okay, between the blood and the oxygens, which is mainly commonly used today. They tend to induce less trauma to the blood because compared to bubble, the membrane oxygenators provides less trauma to the blood. So there are two types of membrane oxygenators. One is microporous, another one is non-porous. Microporous means it consists of pores. Non-porous means it does not consist of the pores. So microporous membranes are commonly used in heart-lung machine, and it can be either plate or the hollow fiber. It may be plated type or the hollow fiber type. So it is made up of the polypropylene. So the microporous is mainly made up of polypropylene. It is stretched to form the pores, which is nothing but it will enlarge to form the pores that allows the sites of the gas exchange, because membrane oxygenators, it consists of a membrane which is permit only the gas between the blood and the oxygen, okay. So based it also stretched to form the pores. In that pores the gas will be exchanged. The non-porous coil type membrane is made up of silicon rubber sheets that form a complete barrier between the blood and the gas. So microporous is made up of polypropylene and non-porous is made up of the silicon rubber sheets. So this type of membrane oxygenators are commonly used in extracorporeal membrane oxygenation. We are using it, it is mainly used in the ECMO application. Okay, so there will be a main membrane also present, oxygenate is present, is which is nothing but heparin. So heparin means it is mainly used to prevent the blood clot. So the heparin coated oxygenators are gaining favor because they are believed to produce less systemic inflammation. So inflammation is bulging and decrease the propensity for the blood to clot in the CPB circuit. First we have to monitor the blood clot also. If there is any blood clot means we can't get enough blood, okay, the blood will also not further, blood will not move to the other parts. So we have to, for that we are using the heparin coated oxygenators. In addition there will be a atrial line filters used in conjunction with the oxygenator to trap particulate matter and gas emboli before the blood is returned to the patient. So we have to look over the emboli, which is nothing but a small blood clot for short duration. We have to monitor that also with the help of the atrial line filters. As blood flows through the oxygenator, it can also be cooled and warmed as necessary to control the body temperature. So whenever blood flows from oxygenators to other parts, there will be a heat exchanger which is mainly used to maintain the blood temperature of the blood. So the body temperature is maintained from the 25 degrees Celsius to 32 degrees Celsius to decrease the overall metabolic requirements. So for maintaining this temperature, a separate heater and cooler unit to control the temperature. So a separate unit is mainly used to control all these parameters. In addition to the extracorporeal circuit for the blood, a separate circuit is used to infuse a solution to the heart, which is nothing but we have to cease the function of the heart with the help of the cardioplegia. So for making that condition, we have to supply some amount of the solution. Okay, so a cardioplegia cannula. Cannula means which is nothing but it is a tubing which is a hole is made on the heart, and through a tube is inserted. With the help of the tube we are inserting the solution to the heart. So a cardioplegia cannula is seen into the heart to deliver a cardioplegia solution to arrest the heart. So main phase is we have to temporarily stop the function of the heart, so that we are using the cardioplegia solution to do that function, so that the surgical field is motionless, and also to prevent the death of the heart tissues.